So now we've got force and gravity notes. We're going to take some notes here. Hopefully this will give you a good visual on some of the things that are going on with force and gravity. So force, let's redefine that if you don't remember. It's a push or pull on an object, and it's measured in newtons. And if I were you, I'd go through and I would highlight these, not highlight, but change the color of these something different. I'm going to make it red. I'm going to do the same thing with this. Use the format painter right there. All right, an example here is friction or gravity. These are examples of forces. So if this were going on, if this is what's happening, you got 30 newtons pushing to the right, pushing this box to the right, and 10 newtons pushing this box to the left. I think you can imagine, if there's, even not knowing much about what newtons are, it's a unit of force. 30 moving to the right, moving it right, and 10 moving it left. Which way is it going to go? It's going to go to the right. So 30 newtons minus 10 newtons equals 20 newtons. Make that red so we can tell. And there's a paint formatter that if you want to go ahead and make a couple of these red, then you can. That may make it easier for you next time, or as you're typing. So net force is the actual force, the actual movement, and applied force is the force that, or we'll just say force acting, the force that's acting on the object. So the net force. The net force is the actual movement, what's moving. So in this case, 20 newtons to the right is the net for, there's 20 newtons of actual movement. The applied force would be all of this together. Let's do the same thing here. See if you can, if you want to pause it and see if you can do this down here at the bottom. Go ahead and do that. Try to get this done at the bottom while it's paused, and then you can come back here to hear what we're doing. So we'll do this. It's going to be 8 newtons to the right minus 5 newtons, which is going to mean that there's a net force of 3 newtons to the right. So this box is going to be moving towards the right. Over here, same thing. It's going to be 700. We're going to do the larger number first. 700 newtons minus 600 newtons gives us 100 newtons. And to do these arrows, I think I prefer arrows. To do these arrows, it's I'm sorry, that's not where I want to do it. I did that wrong. I'm sorry, I was looking at the notes wrong. It's going to equal 100 newtons to the right. There we go. So there's a net force of 100 newtons to the right. So, and think about what would happen here if this person was pushing to the right and this person was pushing to the right. Where would that box go? They're working together, so you would add up however much they're pushing and add this however much they're pushing, and that's how that's the direction it would go. So that should be pretty straightforward. These ones are going to subtract because they're fighting each other. They're not working together. This one is working together, so you add. These forces are fighting against each other, and so you're going to subtract. All right, so let's look at this. Your next slide. Balanced force versus an unbalanced force, which is what we were just talking about. Kind of using the same picture that we just talked about. You got a balanced force and an unbalanced force. Balanced force means they're pushing on each other equally. Unbalanced force means one is pushing more than the other. So let's go ahead and take these definitions down here in the middle. Gravity pulls to the center of the planet or satellite or whatever it is, star, object, whatever it is. It's gravity. Mass is the amount of matter an object has, and weight is a force determined by the gravitational force. I'm going to put something in parentheses and we'll make it kind of small because it's just for it to fit. So you weigh more on Earth than the moon. I'm going to shrink that down so it fits in that line real nice. Go from 16 font to like 14 font, it'll fit. Okay, so we got gravity, mass, and weight. And go ahead and, should have deleted those before, but go ahead and look up what the gravitational force is on each of these planets. Try not to cheat and use what I had down there, but go ahead and look up what the gravitation, you can just use Google, what the gravitational force on each of these would be. So the moon, I'm sorry, on Earth, I'll go ahead and put it back on there, it's 9.8. That's the gravitational force. And then the moon is going to be less because it's smaller, and you'll see a pattern. The smaller planets or smaller bodies are less gravitational force. The larger bodies are more gravitational force.